Alright, so what are logarithms? Well, the way we can think about logarithms is that they're just a way to rewrite exponents, right? So logs are just a way to rewrite exponentiation. So take the equation 2 cubed equals 8, yeah? And we know that. We're past that. That was a couple years ago, right? So we know that's true. And we can rewrite this as a logarithm. So how we do that is by writing log base 2. So here we have 2. So we put the 2 in a little subscript on the bottom. So log base 2 of 8. And usually I like to put little parentheses, but you don't need to. Of 8 equals 3. So we have the log and then the base at the bottom of what it equals to, and then that is equal to the exponent. And so this is how we rewrite 2 cubed equals 8 in logarithm form. Okay, so logarithms have a bunch of properties, and these properties are really useful when simplifying and solving logarithms. So one of these properties is the product property, where log with any base, so base b, of a product, so two numbers multiplied by it together, we're going to use m and n as our variables, log base m times n equals, I don't know if I'm going to have enough room, log base b of m plus log base b of n. Okay, so log base b of m times n equals log base b of m plus log base b of n. And we're going to go through an example. So we're going to say log the base of 2 of, say, 4 times 8. So what this is log base 2 of 32, right? Which is, so, look, this is log base 2 of 32, which we can rewrite as 2 to the power of what equals 32, which is 5. Okay? So, yeah, so this should be 5, and we're going to verify that really quick. So, now that we know that it's 5, we can rewrite this using our product rule. And here, let me erase this real quick. And so here we're going to rewrite this as log base 2 of 4, so this would be our m, log base 2 of 4 plus log base 2 of 8. And we already knew that, we already found out that this is equal to 5. So by our product rule, this should be equal to 5. And we're going to look at this. So log base 2 of 4 is just 2 to the power of what gets you 4, which is 2, right? 2 squared, 2 squared equals 4 here. Let me rewrite this actually. So log base 2 of 4 equals 2, and we're adding that to log base 2 of 8, which is just asking what exponent is needed to raise 2 to 8, which was actually our first example, and we know that's just 3. So it's 2 plus 3, which is 5, and that matches our previous answer. So that's the product rule, and another property is the quotient rule, or the quotient property. So where we have log base b of m divided by n or m over n, equals log base b of m minus log base b of n. Okay, and we can verify that with the same numbers. So let's see, log base 2 of, let's do 8 divided by 4. Okay, and so this would be equivalent to log base 2 of 2, right? Because 8 divided by 4 is 2, which is what exponent needs to be raised to 2 to get to, which should just be 1. And we'll verify that, where we have log base 2 of 8 minus log base 2 of 4, and we know these values, so this would just be 3 minus 2 equals 1, and this matches our previous answer. So that is the quotient property, and you can see the similarity between the two. Now we have the power property, where we have, now we're going to deal with exponents inside our logarithm. So we're going to have log base b of, what should our variables be? M to the power of n. So I don't like that n. M to the power of n equals, and this is a little bit different, equals n times log base b of m. Okay, and let's go through another example using similar numbers. Log base 2 of 2, let's say 2 cubed. Okay, and this should be equal, so this is just saying what exponent of 2 is needed to be raised to get 2 cubed, which logically is 3. And so this should be equal to, then, using our power rule, 3 times log base 2 of 2. Log base 2 of 2 is intuitively 1, so 3 times 1, which is equal to 3. Okay, so that's our power property. And the last one we're going to look at, there's a couple more, but this is the last sort of maybe important one at this step. So we're going to have, let's use a to the power of log base a of x equals, here, let me rewrite that, equals x. And this one doesn't really require a lot of math. We're just going to think about this conceptually. So what does this logarithm mean? This means what power do we need to raise a to get x? So what this will equal, log base a of x, this will equal whatever power a needs to be raised to get x. Well, if you look at our whole equation, we're using this exponent to raise a to x. So logically, this should make sense, right? And so that one's kind of self-intuitive, just kind of logically. And so, yeah. So those are the powers. So those are what are logarithms, firstly. Just a way to rewrite exponents, and we can look at it as, let's say, log base b of y equals x. We can look at it as what power do we need to raise b to get y, and that's what x is. Okay, so we looked at that, what are logarithms, and then what are the properties of logarithms. So here, I'm just going to end it off with a little problem, you know, just to let you consolidate what you know. Log base 2 of 4 cubed times 2. And so this will use the product property and the power property, and It's a little bit of a challenge, but you'll be able to get it with a little bit of work. So, yep, that's what I'm going to leave you off on, and that's what logarithms are.